Hi, welcome to Turkish Engineering. In this lecture, we are going to solve two problems for uniform circular motion, then finish the chapter 3. So, in this question, we are seeing that a satellite moves in a circular orbit. That means we can apply circular motion principles. Why? Because our path is circular and we have a velocity which is just constant velocity, okay? Because it will move with a uniform circular motion. That means the velocity will be constant and there will be just a radial acceleration. So, actually, Earth it will complete just a whole circle, an orbit, a whole orbit within just 98 minutes. So I can say that our capital T, which is time period, will be 98 minutes. So let's say put our value for seconds because we will use SI units and SI units will be just seconds. So 5,880. This is our time period. So I don't know velocity, but I know the time period, so I can calculate for the velocity. What about the radius? Actually, the radius for the Earth plus this distance will give me the radius of the circular orbit. Because the distance which I'm making a circle, this one, the center of this circle will be just the center of the Earth. But the distance from center of the Earth to this satellite will not be just the distance between the surface of the Earth and the satellite. I must add the distance which is coming from the center. So I will add two r's. So this is r1 and this is r2. So the capital R, which is the biggest radius, which is showing the radius of the orbit, will be equal to r1 plus r2. r1 is given in the question. The radius of the Earth will be just 6.37 times 10 to the 6 meters plus the second radius. Actually, this is distance. The distance between above the Earth's surface is actually talking about 640 kilometers above the Earth's surface. So I will put the other distance here, which is 640 kilometers. That means 10 to the 3 meters, right? I will just multiply this one by 1000, which means this one will give me the distance in meters. So let's calculate the radius. Radius will be equal to multiplied by 10 to the 6 plus 10 to the 3. So it's actually how many points? 1, 2, 3, 4, 5, 6. So 7.01 multiplied by 10 to the 6 meters. This is my radius. What about the acceleration? It's actually talking about this, asking about the speed and magnitude of the centripetal acceleration. Centripetal acceleration means the radial acceleration, the other representation for the acceleration of the radial one. So the first part A, I will begin with the part A. So I'm asking for the velocity. Actually, velocity can be calculated from the time period formula. As you know, it will be just 2 pi r divided by velocity. So I can solve for the velocity, switch the time period by the velocity. So I will get 2 pi r divided by time period. 2 pi, and our r is this one, so which is 7.01 multiplied by 9 to the 6 meters divided by how many seconds I have? Just this one. So I will copy and paste here. So it will give me the unit in meter per second because the above is just meter and the below one is just second. So let's make this one 2 pi multiplied by 7.01 multiplied by 10 to the 6 divided by this one will give me 7,490 meter per second. This is the speed. Actually, it will go with a huge amount of velocity, with a huge amount of speed. What about the centripetal acceleration? How can I calculate the acceleration? Acceleration r will be equal to just the velocity squared divided by r. So I know the velocity, which is this one, take square of it and divide by the r, which is 7.01 multiplied by 10 to the 6. So let's divide this, let's take square of this one and divide by 7.01 multiplied by 10 to the 6. So I will get 8 meter per second square. Oh, this is cool. Because this acceleration, this radial acceleration is coming from what? It's coming from what? What's the cause of this acceleration? Actually, to get a circular motion, we must have a force. Actually, we must have an acceleration. In the first part, we must have an acceleration. And the cause of the acceleration is force. You will see that in chapter 4. The cause of the acceleration is force. So, as I said in projectile motion, we have a constant amount of acceleration, which you are seeing that, minus 9.8. And I said, in projectile motion, our applications will be in just low altitudes. In low altitudes, that means we can work with constant acceleration. But I mentioned in the previous lectures in the projectile motion that actually the gravitational acceleration is not constant. When you go to the high altitudes, this acceleration will slow down, will decrease until you reach atmosphere. So outside of the atmosphere, you will see that the acceleration in the y direction, which is just to the center of the Earth, gravitational acceleration will be just 0, because you reach the space, and in the space there is no acceleration until you reach. Actually, there is no gravitational acceleration until you reach to atmosphere of any planet. When you go to the moon, until you reach atmosphere of the moon, there will be no any gravitational acceleration until you reach one of the planet's atmosphere. So as you see, here I have 9.8 of acceleration, but in this case I have just 8. That means when I reach this amount of vertical distance, when I go up 640 kilometers, my acceleration will slow down until it will be just 8 meter per second square. As I said, high altitudes, if I'm working with just 100 meters, 200 meters or 1 kilometers, actually our gravitational acceleration will be constant. But when I'm going up with huge amount of altitudes, so you cannot use this, the constant acceleration, because your acceleration will change. So this is the just finishing of this problem. So let's solve the second problem. So in this question, a woman rides a carnival Ferris wheel, which is this one, with a radius of 15 meters. So let's put our radius from this center when I move to this direction. So our radius will be just 15 meters. Completing 5 turns about its horizontal axis every minute. So 1 minute in 1 minute 5 turns, or we can say 5 turns in 1 minute. So how many turns in second, or what can we say? Let's say 5 turns in 60 seconds. Okay, so one turn will be in how many seconds? So when you just divide this one by 5, so you will see how many turns will be just in 60 seconds. When you divide 60 by 5, you will just take 12 seconds. You will get 12 seconds. That means per each 12 seconds, you are making one whole turn, one whole revolution. Actually, this one will be equal to our time period. So time period is 12 seconds. The period of the actually I finished the first part. The period of the motion will be this one. Magnitude and direction of her centripetal acceleration at the highest point. Highest point, this one. So direction of the acceleration will be downward, right? This one is centripetal acceleration direction. And in this point, actually, our velocity component will be tangential to the circle radius, so it will be just our velocity. How can I know magnitude of the acceleration? I must calculate first the, just move this one, I must calculate the velocity first to calculating A, because acceleration, radial acceleration will be v squared divided by r. I know r, it is just 15 meters, but I don't know v. So v will be equal to 2 pi r divided by just our time period. So 2 pi 15 meters divided by time period, which is 12 seconds, will give me 12 seconds, will give me the answer. Actually, only the velocity. I must calculate the acceleration. 2 pi r, which is 15, divided by 12 seconds, will give me 7.85. 7.85. This is the velocity, which is in meter per second. So how can I calculate the radial acceleration? It will be just this one squared divided by our radius, which is just 15 meters. And this is meter per second squared. Meter squared per second squared divided by meter will give me meter per second squared. 7.85 just squared divided by 15 will give me 4.1. 4.1 meter per second squared. I will have an acceleration. Actually, what will happen when you turn this object, when you turn this Ferris wheel in huge velocities? Let's say that I will move this one by 4 times of, or 5 times of this one. So I will get 5 times of the actual velocity, which is in this case 5 times of it. So take square root of it, and I have this one. So as you see, I have a huge amount of acceleration, which is 100 meters per second square. Actually 10 times, more than 10 times of the gravitational acceleration. When you are falling in a free fall, you will feel a force which is acting on you, your weight. So actually, if this Ferris wheel is moving with 5 times of its actual velocity, and you are just riding this one and you are into one of the cabinets, so you will feel 10 times of your weight, which is pulling you down. You will feel 10 times of your weight. So actually this may damage you. This may damage you because you will feel a force. So that may damage you, or you will feel just a very horrible feeling. So what about but actually in this case you will just feel half of the gravitational acceleration will be just slight acceleration and slight force which is acting on you. So let's see, we calculated the magnitude, and what about the direction of the centripetal acceleration? It will be just downward, as I said. So it will be minus 90 degrees. It will be just minus 90 degrees because the direction will be start from the positive x-axis, and this is the positive y-axis. So the direction is negative 90 because it is downward. What about the magnitude and direction of the centripetal acceleration at the lowest point? So in this point, I will have the same amount of acceleration, but the magnitude will be same, but the direction will be positive 90 degrees. So in part D, the angle will be minus 90 degree, but in the last part, which is the E, so in the part E, the acceleration r will be the same, 4.1 meter per second square, but the angle, which is my direction, will be positive 90 degree because it will be just upward. So the acceleration in r will be just in y direction, and here in the y direction also. But when you reach this point, it will be just in the x direction, and in this point, actually it will be in this direction. So when you reach here, actually when you reach this point, you will not feel any weight which is pulling down, but you will feel a force which is pulling you in the x-axis. It's so cool. When you are riding this wheel, in each point you will feel different feelings. So at the highest point you will feel your weight slighter because acceleration will be smaller than the gravitational acceleration. So you will feel your weight as a half. When you reach here, you will not feel your weight, which is pulling you down, but you will feel a force which is pulling you in the x direction. So this is the application, one of the applications of the circular motion. So I finished our videos for chapter 3. That was just the kinematics of the translational motion. We saw 3 types of motion, which is rectilinear, curvilinear, or projectile, and uniform circular motion. For the next chapter, we will study kinetics of these ideas, the kinetics of translational motion. So see you in the next chapter.